Hello guys, so today I will solve sample problems in compressibility. Okay, so last time I discussed to you the theoretical and the empirical background about compressibility. So now what I will discuss is some problems. So let's try this problem. So here, the 2-meter clay, this is 2 meters. The 2 meters clay layer with a void ratio of 0.92 and specific gravity of 2.72, which having a value of CC, coefficient of compressibility, is 1/3, is overlain with 3-meter thick of sand. So this clay is overlain with 3-meter thick of sand, which these 2 layers of sand, the one is dry and the other one is saturated. So both these 2 sections are made of sand, but this one is submerged, or what we call it saturated, because we have here the location of the water table. Okay, the water table is 1.5 meters below the ground surface. So this is the ground surface. So if a 3-meter thick landfill which has a gamma of 17.3 kilonewtons per cubic meter is placed over the existing ground, compute the consolidation settlement of the clay layer. So these are the given. Okay, again, just to repeat the problem, we need to determine the settlement of the clay layer. Okay, this clay layer, what will be the settlement of this clay? Okay, and based on the given, this clay is overlain by 3-meter thick of sand, but this sand is divided into 2 because the top portion is dry and the other one is saturated, and of course on top of the ground surface you have landfill. Okay, so how to solve this problem? Okay, first, what we can observe here is both the gamma of clay and the gamma of sand is not given, but we have the properties. So the first thing to determine here is the unit weight of the sand and the clay. Okay, so let's compute. So we have here the sand above water table. So gamma of sand is specific gravity plus G MC over 1 plus E gamma of water. So, gamma sand, by substituting these values, this 2.62 and this value of E, okay? And also, take note that if we are considering the sand above the water table, the value here, this is 0 because it's already considered to be dry, okay? So, it will become G over 1 plus E gamma of water, which in turn will give you a value of 17.13 kilonewtons per cubic meter. Okay, so this is the gamma of sand above the water table. Okay? Above the water table. So now, let's compute the sand below water table. Or we can call it gamma sand saturated, using a formula of G minus 1 over 1 plus E gamma of water, gamma of sand saturated will give you 10.59 kilonewtons per cubic meter. Okay? So now, what we can compute is we are done with sand. We will continue with the gamma of clay submerged. So clay is still, this is submerged or saturated. Okay? So gamma of clay saturated, using the same formula, G minus 1 over 1 plus E gamma of water, gamma clay saturated is 8.79 kilonewton per cubic meter. Now, we are ready to determine the value of the consolidation of the clay. And of course, based on the given, it is assumed that you are solving a normally consolidated clay because there is no given pre-consolidation pressure, and which is PC. So therefore, it is under normally consolidated clay, which we will use delta H is equal to HCC over 1 plus EO log of PF over PO. Okay? So H is 2 meters. CC is 1/3. Can you see it? EO is 0.92. And what else? PF is PO plus change of P. This change of P, is actually the pressure from landfill. Okay? While this PO is the effective pressure. So, to do that, we need to determine first the value of PO at considering ground surface. So, what will be the value of PO? The value of PO. So, PO is actually gamma clay sat times 1 meter plus 10.59 gamma sand sat times 1.5 plus gamma sand which is above multiplied by 1.5, and PO will give you 50.37 kilopascal. Okay? While delta P is actually gamma of plant pill times height of plant pill, which is 17.3 times 3 meters, will give you 51.9 kPa. So from that, PF is PO plus delta P, so it will become 102.27 kPa. So we just add this one, PO here and here. Okay, so now we can determine the delta H, which is H is 2, 1/3 is cc, 1 plus 0.92, then logarithmic of 102.27 over 50.37. Delta H is 0.1068 meters, or delta H is 106.7 mm. So this is the value of the consolidation settlement of the clay layer. Again, this one is using this one only. Okay, delta H is HCC 1 plus EO logarithmic of the ratio of PF over PO. Okay, PF is taken by PO plus delta change of P. Okay, so can we proceed to another problem? Can we proceed to another problem? Okay, let's move to another problem. Now, in this problem, we will try to what do you call this one? To solve a problem with a pre-consolidation pressure, so that you can try also. Okay, I mean, to identify whether the problem is normally consolidated or over consolidated. Okay, so let's try another problem. We have here, let's say this is can you see it? This is already what we call groundwater table. So this is again the same sand, but of course gamma sat is already given 18.5 kilonewton per cubic meter. Then you have here clay. gamma sat is equal to 19 kilonewton per cubic meter. E is 0.95. LL is 50. So this is 3 meters, 6 meters, 8 meters. So what is the problem? So a soil profile is shown in figure. A soil profile is shown in the figure. A uniformly distributed load delta P is equal to 50 kPa is applied at the ground surface. Assume CS is equal to 1 pip of Cc. So, the question is, determine the settlement of the clay layer caused by determine the settlement of the clay layer caused by primary consolidation if letter A, the clay is normally consolidated. The other one, the pre-consolidation PC is equal to 210 kPa. Okay, nice problem. So we have here a soil profile having the overburden pressure or delta P 50 kPa with a sand. Of course, it is considered to be clay. So gamma dry, sand, gamma dry, 16 kilonewtons per cubic meter, 3 meters depth. And at a certain distance, here 3 meters below the natural ground or natural ground surface, you have here the groundwater table. Of course, if this is the location of groundwater table, we can say that it's already saturated. So sand, gamma sat is 18.5 kilonewtons per cubic meter. Clay, still it's gamma sat, saturated, 19 kilonewtons per cubic meter. We have E, 0.95, and LL is equal to 50. Okay? So, if we look at the problem, we need to determine the primary consolidation settlement for two considerations. Letter A, the clay is normally consolidated, meaning we will use the first formula if you still remember. Okay? Or in the previous problem that we solved, the same formula will be applied here because we are not required to compare the value of PF and PO. Okay? I mean, the value of PF and PC. Okay? Meaning, for letter A, it's normally consolidated. It's already stated. Okay? But for letter B, you are given with pre-consolidation pressure. Meaning, we need to compare. We need to compare the values of the values of the PF and the value of PC. Okay? PF is the sum of the delta P and PO. And PC is the pre-consolidation pressure. Okay? So we need to compare the two. So let's solve letter A problem. Okay? So for letter A, unlike the previous problem, it's already here. Okay, the density is already here. We can do direct calculation. Okay, so for letter A, delta H is equal to HCC over 1 plus EO, the logarithmic function of PF and PO. Okay, so again for PF it will be PO plus delta P. Okay, so but for PO, again the same procedure, we need to determine the effective pressure at the middle of the clay. Okay, so what will be the pressure here? PO. Okay, in reference with the natural ground surface. Okay, so for PO it will be gamma of clay sat minus gamma water, right? Gamma clay sat minus gamma water multiplied by 4 meters plus gamma sand sat minus gamma water times 6 meters plus gamma sand dry times 3 meters. Okay, so PO is equal to gamma clay sat is 19 minus 9.81 multiplied by 4 plus gamma sand sat is 18.5 minus gamma of water 9.81 times 6 plus, no need to deduct the what do you call this one, the water, because we are deducting the effect of the water because we need to get the effective. And when we talk about the effective, do not include the pressure of the water. But here, the sand here is not exposed to water, so we will take it as it is, which is 16 times 3. So this is 136.9 kPa. Okay? So now, PF is PO plus delta P. Delta P is already given. So PF is 136.9 plus 50 is 186.9 kPa. Okay? So we have PF, we have PO. What is H? H is 8 meters. CC is, we don't know the value of CC, but we are given with 50 of liquid limit. So CC 0.009 times LL minus 50 considering undisturbed sample. Liquid limit is, this is 10. Liquid limit is 50. So 0.009 times 50 minus 10 will give you 0.36. Okay? So, delta H is equal to 8 times 0.36 over 1 plus 0.95 log of 186.9 over 136.9 will give you 0.2 meters, or we can say this is 200 mm. So this is the answer for letter A. Okay? Medyo madilim na class. Okay? So how about for letter B? Okay? Can we proceed? By the way, just a, what do you call this one? I think I made a mistake in the previous problem. Letter A is already solved, right? I just want to clarify something in the previous problem. So here, PO, this is not gamma clay sat, sorry. There is a little bit mistake here. This is not gamma clay sat. This should be gamma clay submerged. Right? Submerged. Okay? This is wrong. Submerged and saturated are not the same. When we talk about submerged, meaning it will be gamma saturated minus gamma water. Okay? The same with this. This is gamma submerged. Gamma sand above 1.5. So gamma clay here, this is submerged. Sorry class. Submerged. What else? This is also submerged, not sat. Submerged. This is submerged. Sorry class, sorry. Okay, I think we are correct now. We are done. So here, gamma clay submerged. Okay, times clay, clay. So 8.79 times 1 plus gamma sand submerged 10.59 times 1.5 plus gamma sand 17.13 times 1.5 will give you 5.37 kPa. Okay? To prove that one, where's that? Gamma clay submerged is 8.79 times 1 meter plus gamma sand submerged is 10.59 times 1.5 plus gamma sand above is 17.13 times 1.5. It will be 50.37 kPa. 50.7 kPa. Okay? A little bit misconception, sorry. This should be submerged. Actually, this is the easiest way. Okay? You can use gamma submerged or gamma saturated to compute the effective pressure. Because here in this problem, we did not use submerged. Why we did not use? Because it's the given. The given is all saturated. So what we did is we deduct the gamma of water. But in the previous problem, only the properties. So we go directly to the gamma submerged. Okay? So let's continue the letter B. Okay, for letter B, the pre-consolidation pressure is PC. Okay? What we will do here is PF is more than PC or PF is less than PC. Okay? This is for letter B. What is PF? PF is 186.9. Ha? 186.9 is more than the less than the preconsideration of 210. Okay? This one. Meaning, the formula to be used is delta H is equal to H CS over 1 plus EO log of PF over PO. Okay? So here, for letter B, only the problem is value of CS, but it's already mentioned here. It's 1 pip of CC. So this is 1 pip of 0.36, which is 0.36 over 5 is 0.072. Okay? So now, delta H is H is 8 meters times 0.072 over 1 plus EO is 0.95 log of 186.9 over 136.9. Delta H will give you 0.04 meter, or delta H is 40 mm. Okay? So, So here, delta H is 40 mm, considering that for letter B, you have pre-consolidation pressure PC, 210. Okay? So the difference between A and B is you need to compare whether the value of PF is more than PC or less than PC. Okay? So if you do not have any question, let's go back to the to the first problem. Okay? Sorry guys I need to repeat this one because I made a mistake. So here, why we use submerge? Because the given are properties. Okay? Unlike in the number 2 problem, gamma sat is the given. Okay? Because to determine the effective pressure is always gamma sat minus gamma water times the height if soil is below water table, right? So this gamma sat minus gamma water is actually called gamma submerged. It's the same name, Gamma submerged is actually gamma sat minus gamma water. Again, if the properties are given, you can compute directly with the gamma submerged. But if gamma sat is given, use as gamma sat minus gamma of water. Okay? So that's it. Let's try another problem next meeting. Thank you.